Hello, you're welcome to Chemistry Hangout. How are you guys doing today? I want to believe we're fine. And you can see I'm very happy today. And the reason is because my joy knows no bound. Okay, my joy today is limitless. Why? A lot of my students that are YX students have communicated to me and they have been checking their result, and it was wonderful. It was wonderful. And I tell you, I am very happy to be a blessing to them, and I'm thanking them too for being a part of this channel. I love you guys. Keep sending your results to me. For some of you that have not sent your result to me, I want to see it. But a lot of people that have sent their result to me, the result was fantastic. And that is one of the aim of setting up this channel. We are setting up this channel to make people see that you can actually do all these things yourself without examination malpractice. And you can bear me witness, for people that have been on this channel for some time now, you will see we have been doing our best to make sure that all these things are simplified, especially doing them practically the way it should be, so that we can carry it out in our various centers and see how wonderful and interesting chemistry is. So for all my students all over the place, I want to say congratulations to you guys. Well done. I'm very happy. I'm very happy this morning. And I want to say congratulations in advance too to my NECO students. You know, a lot of them have reached out to me, because if you check our channel, the NECO prediction we did was accurate. I would say the NECO prediction was 97% accurate. And if we say it is 97% accurate, it means a whole lot of students were able to do those exams themselves. So I'll be waiting for their results when it comes, for that is NECO. But for my ex-students, I love you guys. I love you guys. If you are new to this channel, this is the right place to be as far as chemistry is concerned. So if you are new to this channel, click on the subscribe button. And if you are not new to this channel, if you are already a subscriber, I want to welcome you chemically to today's episode of Practical on Chemistry Hangout. I love you guys. I'm very happy, and that's one of our joy as educators, to see our students doing very well. So thank you so much, and I want to appreciate you guys for your prayers, for your support. A lot of people have been supporting us on this channel. Thanks for your support. Thanks for your prayer. Thanks for your motivation. I am saying thank you. So let us pay attention to what we are going to be doing today. And I've said that don't only visit this channel when you are writing exams. There are a lot of things we are going to be doing. A lot of practicals. You can bear me witness. I'm a lover of practical. I love doing practicals. And that is because that is an affirmation to some of the theories that are postulated in science. Without experiments, then science doesn't exist. So that's why you see most of the time I just want to do every possible best to do all these things theoretically and explain practically. So my students, congratulations once again. You're welcome to the episode of Teaching on Chemistry Hangout. Now, very important, the reason why I had to do this, you can see, after I dropped the NECO video, I've been a bit busy, trying to do a lot of things too. But I had to do this for Jupeb students, okay? And the reason why I'm doing this is because if you check the channel, 2022, I did this Jupeb, practical, just to give the people that will be doing it this year, to give them something to look at, or to look for, or to expect. Do you understand that now? So I actually did that to actually, let them see what to expect if they are doing it for this year. And it has helped a lot of people. But I got the confidential for this one a bit late. So though I did the analysis for some of them, and they were happy, but I had to do the practical because I discovered something, and I'll be explaining that on this channel. So this practical is basically for Jupeb 2023, the question, and I'll be providing solution to. This is the question that I've done the exam though, but so that people that will be doing it next year too, this one too will be a reference to them. Should I be very busy as at that time and I'm not able to do video, if you can watch this too, at least it will give you an hint of what you should be expecting. So you're welcome once again. So let us see what Jupeb did for this year. You are provided with the following: solution of A containing 1.83 gram ACl in 500 centimeter cube of solution. Solution B, a saturated solution of an alkaline earth metal hydroxide containing 0.71 gram of salt in 1 gallon cube of the solution. 3 methyl orange indicator, you can see that. So they said pipette 25 centimeter cube portion of solution B into a conical flask, add about 2 drops of methyl orange and titrate against solution A from the burette. So don't worry, this one will be solution B, a saturated, solution B, a saturated or a saturated solution of B. That's what they are saying. So that's not a problem. So 2 drops of methyl orange and titrate against solution A from the burette. So repeat the above procedure twice using fresh portion of solution B. Please, I always advise students when you are taking any particular exam, read the instructions. Read the instructions. Very, very important. Read the instructions. So let me do my example, then I'll perform the practical and let's see what happens. So let me have burette. Let me have burette readings. Okay? Let me have burette readings. But here, they are saying repeat the procedure twice. It's not like there is anything wrong if you are repeating it 3 times. Like the way we normally do in the normal titration, we do rough, we do first, second, and third, or we do rough, we do first and second. You understand? But here they said we should repeat it twice, so I can just have first and second. You can do your own rough first, second, but I love obeying instructions. That's the instruction that I should just do it twice. So maybe they are trying to, make us be able to, manage our time very well and do the practical carefully. So that means I might not do rough, I'll just do first and second based on what they are saying in the instruction. But if you have done rough, first and second is not bad. You are still getting the same, if you have done it very well, your average title should still be, still correct. So that's the problem. So for this one, I will just do burette readings, then I will do final readings, okay? I'll do final readings. I'll do initial readings, okay? So I have this in centimeter cube. The units, don't forget, very important. Says is a table, okay? So I'll just do my first, that's centimeter cube. Then I will do my second, that's a centimeter cube also. I hope this is clear. So there is no problem about this. We are just trying to follow the instruction. But if you do your rough first, second, if you decide to do your rough first, second, and third, but I just love following instructions. So this is my initial reading. So here I can have volume of acid used. Okay? I want to believe this is clear. This is very clear. So let's have our volume of pipette here. Let's indicate it. The volume of pipette I'll be using is 25 centimeter cube. And the indicator they have given us before, though in the question, but I still love writing it, methyl orange. Well stated. Okay, so we want to perform the practical now. Very, very important. So let's quickly start the practical very fast. Let's quickly start the practical very fast. Okay? So let's start the practical very fast. Okay? So this is my solution A. This is my solution B. They would have prepared it for you in your various center. So this solution A, this solution B. So solution A, according to the question, goes directly into the burette. So I have this going directly into the burette. Okay. Let me release a bit of this so that I can have on 0. Okay, fine. Now on 0, very important. I'm pipetting my B now. Okay. Okay, of B now you can see that's going directly into this place. Okay. So they said we should add 2 drops of methyl orange indicator. So this is my methyl orange indicator. So we have 1 and 2. Okay, you can see the color now. Okay, so don't forget, before you start titrating, you have to remove your phoneme, very important. Then it's on 0, that's my initial now, on 0. So let me start titrating. Wow. It's almost changing, you can see. Can you see that now? It has changed. Let me see. 4, okay, 4.80. Okay, so my initial here is 0.00. My final is 4.80. I'm still going to talk about this, but let's just finish. So let me start from 4.80 again, which is my initial. That means I will start from where I stopped, since, you know, let me just put it here so that I will not waste my time. Okay. Let's solve the facts. Okay. So I'll go again. Okay. Now the reason why the base is looking like this is because the base is insoluble in water, so that's why you have all this, you know, like deposits here. But nevertheless, it will not stop what we should do. Okay. So we add another 2 drops. Okay, 2 drops again. Let's start from where we stopped. Can you see this? Can you see this thing? Okay, let's check. 9 point. I think this is it 5 or 6. Okay, in between. Okay, let me say 9.60. 9.60. I want to believe you understand the reason why here is 4.80, meaning I did not refill. You know, I didn't refill, that's why I had to do this. So this will be 4.80. Okay, this should be 4.802. I hope this is clear. Now let me talk about this. I have seen, let me put this here so that I can explain something here. Let me put this here, because I'm done with the titration. That's just what I want to do. But let me explain this. I have discovered that we have, you know, we students, even teachers, has some kind of emotional feelings when it comes to titrating, because there is this mentality that if your title value is small, the practical is not correct. That's not true. What determines the title value of a particular titration is the concentration of what has been prepared. Please get that, because 2 years ago, I think for WAEC, I did a practical and my title value was less than 10. You know, a lot of people were saying like, the title value should not be less than 10, it is too small. Even this year, if I'm not mistaken, this year or last year, even this year, the title value was around less than 10 or thereabout. You know, I could see people like, no, it's not supposed to be like that, it's supposed to be high. No, we cannot determine title value by emotions. We cannot determine title value by assumptions. That is why it's a practical work. We cannot determine title value by subjections. So let's carry out the practical, because a lot of people will see this now and we're like, why will the title value be very small? The title value will be small because the concentration of what has been prepared is what determines the title value, not my own assumption. And that's why most times when I carry out my practical, I don't get worried, because I know if you have prepared the right reagent, if you have followed the concentration given, because there is a concentration given, if you have followed the concentration given, then don't worry about your title value. Make do with what you have as your title value. So I am not worried. Even if I get 1 as my title value or 2, I don't get myself worried, because I am sure I have prepared the right reagent. And that's why I always tell teachers, please know how to prepare the reagent accurately. We have a video for that. More than 500 teachers has gotten that video. If you have not gotten it, you can reach out to me so that I will tell you how to get it. These are one of the problems we face as teachers. When your preparation of the reagent is not correct, definitely your title value will be affected. So my number is on the screen. You can chat me up to actually know details about that very particular video. It has helped a lot of teachers, and I'm sure if you need it, reach out to me. It will help you very, very well. So please don't worry about your title value. Worry about what you have prepared. If what you have prepared is right, then your title value is supposed to be close to correct. I hope that is clear. So I don't have an issue with the title value being 4 or being 2, because I know I have prepared the right reagent. So I'm going to make do with this. This is my titration. I am done. I hope that is clear. So let's learn that. Even some students, when they see 4.80 as title value, they'll be like, is this thing correct? This thing changed quickly. The one I've always been doing doesn't change quickly. No, we don't determine title value by that. We determine title value by the concentration of what has been prepared. We now show us what the title value will be. Okay? So don't determine title value by emotions. Don't determine title value by assumptions. Determine your title value practically. I hope that is clear. So very, very important now. They now said, what's the next thing? They said repeat the above procedure twice. I've done that. Calculate the average title. So the average title here is, follow the numbering place. That's 3. Repeat the procedure. So this table should be number. Repeat the above procedure twice. This is first portion. So this table should be 2 according to the question, the level of the question. Then 3. Calculate the average. Calculate the average title. So I can just put these 2. So average title is 4.80 plus 4.80 divided by 2. So the average title is, this should be what? Sorry, okay. So this should be 9.5. This should be 9.60. I mean over 2. Okay, so the average title is going to be 4.80 centimeters. This is clear. Please, okay, let me put this here so that you can actually see, because I'm actually using. Let me just put this here. Okay, I think this will be clear now so that I can see it. Okay, so the next one, that's the third one now. The fourth one, they said write a balance. The fourth one now. They said write a balanced equation for the reaction. What's the reaction? HCl, and they said it's an alkaline earth metal hydrogen. This is what they gave. So we did not know this M. This M is missing, but we know it's an hydrogen because it carries the the hydrogen group. So we know this is an hydrogen. They've even given us an hint of what M is going to look like. Alkali earth metal. If you understand the periodic table, you know alkali earth metal, they are group 2 elements. Alkali metal group 1, alkali earth metal group 2. So they said this M is a member of the alkali earth metal. So they are just giving us an hint. Okay. So now say write a balanced equation for the reaction. So a balanced equation between HCl, don't forget aqueous, plus why is it aqueous? Because it's the liquid portion we use, and NOH2, okay, aqueous 2. What will it give us? Please, that's why you have to understand chemistry. Don't cram all these things. This is an acid. Definitely this is a base because of the weight. And you know when acid reacts with base, it's going to give us salt and water, and that will lead me to how I am going to write this. So here, what will I have? I will have this, then this will be MCl2 plus, I will explain this, H2O. This one will be liquid, this one will be liquid. Why did I write? Because you've already given me an hint. Alkali earth metal and group 2, meaning the valency will be +2. That's the meaning. So, which means this M now has valency of 2. That's what they are actually telling me here. So the valency of this M is this, and I know chlorine used to have minus. So when this is just like M, we have 2, and chlorine we have, you can see, 1. So when they react together, they will exchange their valency. So it becomes this. That's how I'm able to write this. And I know water now. Normal. So what we do after this, we balance the equation. So let's see. Hydrogen is 1 here, plus this, that's 3. Hydrogen is 2 here. Okay? If I put 2 here, hydrogen will be 2 plus 2, making 4. Hydrogen will be 2 here. I'll put 2 here. Hydrogen will be 4. So let's see. Hydrogen is 2 plus 2, that's 4. Hydrogen is 4 already, balanced. Chlorine here is 2. Chlorine here is 2, balanced. N is just 1. N is just 1, balanced. Oxygen is 2. Oxygen is 2, balanced. Can you see that? So they are testing your knowledge of balancing chemical equations. So that's number 4. You can see these things. If you are used to this channel, you can see we have been doing a lot of this thing on this channel. So you need to understand this. So 4, write the balance equation. We have done that. Now B, they said calculate the concentration of solution A in mole per dl. So that's B, now figure 1. I hope that is clear now. Calculate, they said calculate the concentration of solution A in mole per dm cube. Okay, let's go back to A. Solution A contains 1.83 ACl in 500 centimeter cube. Can you see that? I have told us in this channel, that the standard measurement in chemistry is 1 dm cube, which is 1000 centimeter cube. I've always said that. So what will I do? What will I do here? I'll just say the question said 8.3 gram. 8.3 gram in what? In 500 centimeter cube. But the question says solution A in mole per dm cube. Per dm cube means 1000 centimeter cube. So if I use this value to calculate, what I'll be getting will be per 500. So I need to get per 1000. So I'll just say 1000 now will be equal to what? X. Can you see that? So my X will be 1.83 times 1000 over 500. So I'll use my calculator. 1.83 times 1000 divided by 500. So that is giving me 3.66. That's giving me 3.66 gram. I see. So this one now means 3.66 gram in 1000 centimeter cube, which means this one is representing the mass now. But the mass I should calculate it in mole. So I'll come and say my mole is equal to mass over molar mass. Can you see? These things are steps by step, step by step. So meaning I have gotten the mass in 1 dm cube. So I want to change the mass now to mole in 1 dm cube. So if I've used this 1.83, it means I'll get the mole too in 500 centimeter cube, because the 1.83 is in what? Is in 500 centimeter cube. I hope that is clear. So the mole now. So what is the mass? I have the mass. So let me calculate the molar mass now. The molar mass of HCl. That will be what? They are giving us hydrogen, they are giving us chlorine. Can you see that? So it will be 1 plus 35.5. And that will give us 36.5 gram per mole. Please, the units are very, very important. So the mole now will now be equal to, what is the mass? 3.66 gram. Okay, that is now per dm cube. Don't forget, over 36.5 gram per mole. This is how you know you are correct. Gram will cancel gram. So your answer will now be mole per cube. So the mole now is going to be, let's see, 3.66 divide 3.66 divide 36.5. That's 0.100. Okay, that's 0.100 mole per dm. I want to believe this is clear, very clear. Okay, let's continue. Let me take my. So now, what's the next thing? They said the number of moles of A in the average titer. The number of moles of A. Okay, let me wrap up this place, because I've done this, because I want to keep, referring us back to the question. So I've done this, I've done this. So if you are a student that you really want to, get the whole of this thing, you take your pen and write the questions down, then you can follow the solution. So let me rub up this place. I've answered those questions. So the next question I'm asking now is this: the number of moles of A in the average titer. So that's what I'm asking. The number of moles. I've given the formula for calculating number of moles severally on this channel, and that is what? Moles. That's A. That will be concentration times volume over 1000. I have given the reason why we are dividing by 1000. Okay, because the volume is in centimeter cube. You can see the volume is in centimeter cube. Look at it. So I want to convert to dm cube because I'm looking for number of moles. So I want to convert to dm cube because the number formula I've given that before, that my N is CV. That's the formula. Number of moles is concentration times volume. So, but because it has to be, this one is in centimeter cube. If the volume is in dm cube, I will not divide again by 1000. So, but because the volume is in centimeter cube, that's why I had to divide by 1000. So that's clear. So our N will now be What is the concentration? Because they said the number of moles of A. So the concentration of A, we have calculated that. That's 0.100 times the volume, 4.80. 4.80, then we divide by 1000. So our number of moles, let's go 0.100 times 4.80 divide by 1000. So this giving me 0.00048 moles. Can we see that now? So that is sorted. The next one, they said the number of moles of B. Now please pay attention to this. They said the number of moles of B. We are getting the number of moles of A. But if you look at B, they gave us only the mass of B. And there is no way I can, do this mole here because M here is missing. And that's where the knowledge of stoichiometry is important. Relationship between, the reactant and the product. So that's why this equation must be correct. Because if this equation is not correct or you do not balance this equation, I will not be able to use this, this stoichiometry to actually do this. So I want to use stoichiometry here. So pay attention. The number of moles of A in the average titer, that one I've decided. The number of moles of B used in each titration. Don't forget I've done this, the number of moles of A. This is it. So the third one, the number of moles of B now. So what do I do? Now look at this. Look at this. The number of moles of B, that's where I am now. The number of moles of B, that's 3. Now, how do I get the number of moles of B? I'll go back to the equation. I'll say from the equation of reaction, number A, this is A, don't forget this is B. So 2 moles of this gave 1 mole of this because there's an invisible one here. Do you see that? 2 moles of this gave 1 mole of this. So I will say from the equation of reaction, 2 moles of HCl gave what? 1 mole of MOH2. Can you see this is clear? So if 2 moles of this gave 1 mole of this, this is the number of moles of HCl. And I said if 2 moles of this gave this, then it's 0.00048 moles. We give what? We give X. So from here, my X will now be 0.00048 times 1 over what? Over 2. So my X will be 0.00048 divided by 2. So and that's giving us 0.00024 sorted. That's why we have to understand chemistry. That's that. So because if I've got the number of moles of A, then there's a relationship between A and B in the equation, which is 2:1. And that's how I solved that. So the number of moles of B used in each titration. This is it. I've solved that. Then they now say 4. Look at the question now. 4. The molar concentration of this in solution B. Look at that. The molar concentration, meaning they want you to get it in mole per dm cube. Now that's the meaning. The molar concentration. The molar concentration is a mole per dm cube. So what do I do? If you look at this place, I cannot really use mole. I told you, I cannot use mole equal to mass over molar mass with this. Why? Because M is missing. I don't know M. So what do? I will resort to my titration formula, the molar concentration. So I'm saying 4. So I will use CAVA over CBVB equals NA over NA. So what is my CA? That's what I have done here, 0.100 times what is my VA? Is already in here over what is my CB? That's what I'm looking for. Times volume of base, that's 25. Okay, equals to number of acids. You can see from the equation of reaction 2 to 1. That's why you must check your steps. You must check your steps. Very important. You must check it. So from there we make CB the subject. Then we have 0.100. Okay, times 4.80 over times this one will be okay. This 1. That's this. Then over 25 times 2. Can you see that one? So from there, our CB is going to be what? Let's see. 0.100 times 4.80. Okay, now we divide 50 because 25 times 2 is 50. So that's giving us 0.0. I see that because it asks us to calculate the molar concentration. So we have 0.100 times 4.80. Let's be sure. Then divide 50. Okay, that's 0.0096 mole per dm. That is sodium. I want to believe you are following. These are how you dissect chemistry questions. These are how you dissect. So the fifth one now said the solubility of this at 298. Look at that. They want to actually convince students with that question. Because the formula for solubility, I think I did one of that video. If you go back to some of my videos, I talked about solubility in one, and then using titration to determine the solubility of a substance. I think I explained that in my last video. So for solubility, we know the formula is mass over molar mass times 1000 over volume. That's for solubility. But don't forget that the unit for solubility is mole per dm cube. You see that? So the formula for solubility is supposed to be mass. Okay, it's given here. But the molar mass is not given because you cannot calculate for N. You just want to test your understanding of, your understanding about chemistry. So the mass they gave us, if I want to use this formula, look at what I'm saying. If I want to use this formula, solubility is mass over molar mass, which is the general formula for solubility. Though you can calculate some questions on solubility without even using this, but this is the general formula. So mass is there in the question. You can see I cannot even calculate molar mass. Molar mass is not there because N is missing. Can you see? Even the molar mass is not there because I cannot. You can see I cannot actually use the molar mass. So which means I cannot use this. But we have indirectly calculated the solubility because don't forget the unit for solubility is mole per dm cube. Yes, this is the unit for solubility, mole per dm cube. And what is the unit here? Mole per dm cube. Can you see that now? So the solubility V is solubility. V is solubility. Here will still be 0.0096 mole per dm cube. That's the solubility. You know why? It's already in mole per dm cube. That's the unit for solubility because they know you cannot calculate the solubility because of what they have given you in the question. So they expect that you should know that this very particular concentration of base is still the solubility. Okay? Because the volume that is even collected is not given because we collected just 25 out of the concentration of base, which is the VB, which is the volume of the base. Do you get that now? So the solubility is already in this. And if you look at this formula, you can see we have factored the volume collected, 25 collected here, we have factored it here. So we use that to look for the CB, having no other parameters. So the solubility here is 0.0096 mole per dm cube. So the last question is, the last time we should get the relative atomic mass of N. Let me do that here. Let me do that here. So if you wish to, have the question, you can just go back to the beginning of the video, write the question down so that you can follow those calculations. So the last one, which is the sixth one, is that the relative. So we want to know the relative atomic mass of what? Of M. So how can we get that? We know that our mole, from this formula, we know that our mole is equal to mass over molar mass. But we want to get the molar mass first. So do we have our mass? Yes. Do we have our mass? Yes, they are giving us 0.71. That's our mass. Do we have our mole? Yes, which is in dm cube. This is it. So we can just make molar mass the subject here by saying molar mass is equal to what? Equal to mass over mole. So our molar mass is equal to, what is the mass? 0.71 gram over, what is the mole? Is 0.000, yeah, 0.0096 mole per 3 mK. I think that's clear. Also, this will be because according to this, in 1 dm cube, you can see containing 0.71 gram of salt in what? In 1 dm cube. So this one too will be C because it's given already in the question. gram per DMK. So from there, what do we do? Let's continue. So our molar mass then is going to be, let's use our calculator, 0.71 divide 0.0096. That's 73.9. 0.71 divided 0.00, so that's giving us 73 points, let's say 9. So from there, what do we do? 73.9, that will be gram per mole. So from there, we can now say MOH this, can you see that, is equal to, this is the molar mass, 73.9. Do we see that now? So from here, M plus, they are giving us oxygen, so oxygen will be 16 times 2 plus hydrogen 1 times 2 equal to 73.9. Have we seen it together? So from here we have M plus 32 plus 2 equals to 73.9. So from there, what do we have? We have M plus 34 equals 73.9. Are we still together? We should still be together. So from there we have M will now be 73.9 minus 34. So our M will be, let's see, minus 73.9 minus 34. So that will be 39.9. Can you see that? So if it is 39.9, approximately M is going to be 40. Can you see? So what is the element that has the relative atomic mass of 40? That is what? Calcium. So this formula they gave, that's why chemistry is interesting. This formula they gave is calcium hydroxide. Correct. You can see that's why I didn't worry about my theta value. You can see because I've done the right preparation. So if I've done the right preparation, then I'm not worried about my theta value. So the M that they gave us, the relative atomic mass of M is 40. So they didn't ask us to name the elements. So I'm just trying to explain that because we have gotten 40, it means that this M is what is calcium. And that's what the Jupeb student was given this year. So go over this video. Even if you are not a Jupeb, if you are an A-level student, especially for university students, 100-level students, you know, some of you are still going to be taking chemistry practical as one of your courses. So all these things are what they are still going to be teaching you. Okay? All these things are what they are still going to be teaching you. So go over it over and over again so that you can get yourself, you know, accustomed to all these chemistry questions. They are very easy, and that's why we are always providing the practical year on this channel. So this is how what they gave the Jupeb students, and I want to believe for people that actually didn't get it right, this is like a correction for you to know how to do it next time. And for people coming to do Jupeb again, you can use this as a reference to study how to know how the question will look like and to use it as a reference to actually study it. So if you are just watching this YouTube channel, this is the right place for you to be. As far as chemistry is concerned, this is the hope of chemistry. So if you have not clicked the subscribe button, please kindly do so and share this video, because what is on this video or what we have for you on this channel is more than what only you can benefit from. So I will kindly urge you to, you know, share this video, to comment, to like it, share it to your friends that you know will need this video. It will help them immensely. So it's more than only what you can consume. You need other people too to benefit from it. So you can share the video, introduce Chemistry Hangout to them, tell them if they are finding chemistry difficult, Chemistry Hangout is the place to be. So if you are new to this channel, kindly subscribe. And if you are already a subscriber, thank you so much. So there will come another time for another wonderful episode on this channel. For GC students, I will be coming with my content. I have not forgotten you guys. Some of them have reached out to me, so I will start dropping GC content, you know, what you should expect in GC as soon as possible, so that you can have time to ruminate over it and, you know, and study it. So there are a lot of things we want to do on this channel. And if you are a teacher, I have spoken about preparation of laboratory reagent. I have so much talked on that. There are fantastic videos for us that will teach us all these things, and that will move us from an average chemistry teacher to an A chemistry teacher. You can't be a chemistry teacher and not know how to prepare reagent. No, that is, that's not fair. So if you're a chemistry teacher, my number is on the screen. You can reach me through that number. That's my WhatsApp number. You can reach me through that WhatsApp number, okay? So that we can learn together, we can, ruminate together, we can actually talk, chat as far as chemistry is concerned. So I can help in my little way if there is anything you want me to do as far as chemistry is concerned. I love you guys. Till I'll be coming again to give us another wonderful, teaching on this channel. Stay chemically active. Bye bye. I love you.